Did you know that our solar system is almost entirely empty? It might seem hard to believe given the plethora of celestial bodies we know of, planets, moons, asteroids, comets. But the space between these entities is largely vacant. Imagine, if you will, a cosmic dance where the dancers are light years apart. The distances between planets are so vast, they make our terrestrial miles and kilometers seem insignificant. For instance, the distance between Earth and our closest neighbor, Venus, fluctuates between 24 million to 162 million miles. To put it into perspective, you could fit over 6,000 Earths in the gap between our world and Venus alone. And that's our nearest neighbor. The emptiness extends far beyond into the outer reaches of the solar system and beyond. So remember, when you look up at the night sky, you're seeing a lot of empty space. Don't forget to subscribe to my channel for more fascinating facts about our solar system. You may have experienced a windy day, but it's nothing compared to Neptune. Now imagine yourself on a planet where the wind speeds are so high, they could sweep you off your feet in an instant. We're talking about Neptune, the windiest planet in our solar system. The winds on Neptune are not just a breeze, they're a storm. These winds blow at exceptional speeds, reaching up to 2,400 kilometers per hour. That's faster than the fastest car in the world, and even faster than the speed of sound. These extreme winds are caused by the planet's high-speed rotation and the heat from its interior. And unlike the winds on Earth, Neptune's winds don't die down. They're relentless, constant, never-ending. So the next time you complain about a windy day, remember Neptune. Because compared to the gusts on that distant blue planet, our windiest days are just a gentle zephyr. Imagine a day that lasts 176 Earth days. Welcome to Mercury. The smallest planet in our solar system, closest to the Sun, has some truly extreme days and nights. This is due to its elliptical orbit and slow rotation. Unlike Earth, which spins on its axis once every 24 hours, Mercury takes its sweet time, rotating just over every 58 Earth days. This slow rotation combined with its elliptical orbit means that a day on Mercury, from one sunrise to the next, lasts approximately 176 Earth days. Imagine that, waking up to a sunrise and not seeing another until nearly 6 Earth months later. Mercury's long days and nights are a testament to the diversity of our solar system's celestial bodies and their unique characteristics. So if you thought your day was dragging on, just remember, it could be a whole lot longer. One Mercury day equals nearly 6 Earth months. The greatest storm in the solar system has been raging for at least 400 years on Jupiter. This is not a storm like any we know on Earth. It's a tempest of epic proportions, a swirling mass of gas and cloud known as the Great Red Spot. This colossal storm has been observed by astronomers since the 17th century, and it's been going strong ever since. It's a hurricane that's been raging for centuries, with winds whipping around at hundreds of kilometers per hour. The Great Red Spot is not just notable for its longevity, it's also incredibly large. In fact, it's so large that it could easily encompass 2 or 3 Earths side by side. Can you imagine a storm that big? Despite being studied for centuries, the Great Red Spot still holds many mysteries. Mysteries that scientists hope to unravel in our ongoing exploration of the universe. This storm is so large that it could swallow the Earth whole. Our moon is slowly drifting away from us at a rate of 3.8 centimeters per year. This might be insignificant, but over time, this slow lunar retreat will have a profound impact on our planet. As the moon continues its cosmic journey away from us, the gravitational pull between the Earth and the moon weakens. This phenomenon, in turn, affects the rotation, gradually slowing it down. Now imagine a day that lasts longer than 24 hours. A leisurely paced Earth, taking its sweet time to complete one full rotation. That's the future we're headed towards. Our days and nights, as we know them, will eventually become longer. This process, however, is not happening overnight. It's a slow dance between the Earth and Moon, playing out over millions of years. So, while we won't notice the change in our lifetime, the future inhabitants of Earth will a different rhythm of life. In a few million years, our days will be noticeably longer. Before we move on to the next scene, don't forget that if you're enjoying this video, hit that subscribe button. If you could find an ocean big enough, Saturn would float in it. This charming fact is a testament to Saturn's surprisingly low density. Despite its colossal size, its overall density is less than that of water. This means that theoretically, if you could find a body of water vast enough, Saturn would bob around like an apple in a bucket. Now let's focus on Saturn's most striking feature, its dense rings. These rings are not just for show, They're composed of countless pieces of ice, dust, and rock, all orbiting the planet at breakneck speeds. Some of these particles are as small as a grain of sand, while others are as large as mountains. They span up to 280,000 kilometers. That's about 3/4 the distance between the Earth and the Moon. In essence, Saturn is not just a planet, it's a miniature solar system within our own. Saturn is the solar system's own floating spectacle. While most planets spin vertically, Uranus prefers a more horizontal approach. Unlike its celestial neighbors that twirl around their axes like tops, Uranus spins on its side. This peculiar alignment is the result of a colossal cosmic collision that knocked Uranus off its feet, so to speak, billions of years ago. Imagine a planet spinning like a rolling ball instead of a spinning top. That's Uranus for you. This odd orientation leads to extreme seasons. During its solstice, one pole gets continuous sunlight for about 21 years while the other is in absolute darkness. The sideways tilt also means that Uranus's magnetic field is lopsided. It doesn't pass through the planet's center, leading to a wild and wacky magnetic field that opens and closes every day. So while we might chuckle at its name, Uranus is no laughing matter. It's a unique, fascinating world that challenges our understanding of planets and their behaviors. Uranus truly dances to the beat of its own drum. Since its discovery in 1930, Pluto hasn't completed a single orbit around the Sun. Now isn't that a thought to ponder? Indeed, the tiny icy world takes its sweet time to circle our star. To put it in perspective, it takes Pluto roughly 248 Earth years to complete one full orbit around the Sun. Yes, you heard it right, 248 years. This mind-boggling duration is due to Pluto's elliptical and tilted orbit, which takes it between nearly 3 billion and nearly 5 billion miles away from the Sun. Compared to Earth's nearly circular orbit at a comfortable 93 million miles from the Sun, it's no wonder Pluto's journey is a slow one. Just think about it. The last time Pluto was in the same spot in its orbit as it is today, Earth was in the early stages of the Industrial Revolution. Now that's a slow journey. Pluto really takes its time. The Sun makes up a staggering 99.86% of the mass in our solar system. Imagine a celestial body so immense, so formidable that its gravitational pull keeps everything in check, from the smallest asteroid to the largest planet. That's our Sun, an astronomical giant, whose mass is so colossal it comprises nearly all of the solar system's mass. Its gravitational force is the glue that binds our solar system together. It keeps planets, including our Earth, in their orbits, preventing them from drifting off into the vast expanse of space. This same force also shapes the trajectories of comets and influences the paths of asteroids. In essence, the Sun's gravity governs the cosmic dance that unfolds across our solar system. It's not just size that matters, it's the influence. The Sun's mass and its resulting gravitational force make it the dominating force within our solar system. Without the Sun, there would be no solar system. Did you know that comets have two tails? Yes, you heard it right. Comets, those icy objects that hurtle through our solar system, present a fascinating spectacle as they approach the Sun. As they get closer, they develop not one but two tails. One is a dust tail. Sunlight pushes against the comet, causing it to shed dust particles. These particles are then swept back by the sunlight, forming a bright curving tail that follows the comet's path. The second tail is a gas or ion tail. As the comet's icy nucleus warms, it releases gases. These gases glow, creating a second tail that points directly away from the Sun. But here's the catch. These two tails always point in opposite directions. This is due to the pressure of the solar wind, a stream of charged particles that the Sun constantly emits. Comets, the celestial bodies with a dual personality.